Good afternoon, good evening, everyone. Thanks for spending some time with us today. Today, I'm joined by Nelson Petracek, Global CTO at TIBCO Software, and Jim St.Clair, Executive Director at the Linux Foundation, the Public Health Group. And today, we're going to be talking about a very interesting topic, digital twins and self-sovereign identity. So Jim and Nelson will explain, how these two concepts, they intersect and then they get connected. And we want to try to keep this session as interactive as possible. So the easiest way to interact with the speakers today is through the Q&A section of Zoom. So if you have any questions, don't wait until the end. Start typing your questions, and then we'll basically go through the questions as they come up. So with that, Jim, Nelson, please take it away.
Thank you, my friend. You could move on to the next slide. I think, first of all, one of the useful things that Nelson and I would like to iron out with the audience, of course, is just what is a digital twin? And as you can see from the Gartner definition here, it's a digital representation of a real-world entity or system. The implementation of a digital twin is an encapsulated software model that mirrors a unique physical object, and data from across multiple digital twins can be aggregated into composite views for things such as power plants, cities, and their related processes. Speaking from the standpoint of Linux Foundation Public Health, our interest around digital twins, and for some of the work TIBCO is doing, is the concept of how can digital twins and the Internet of Things IoT devices be combined to be used in healthcare cases with healthcare information and serve as digital representations of people and patients for healthcare delivery. Next slide, please. You can see here the concept of digital twin functional groupings, whether they're involved with process mining and integration services, whether it's data collection, data processes, stores, and compute, the data science and data visualization aspects that all build together algorithmically and functionally into what we call digital twins around a process, an entity, a patient, a workflow, etc. So the idea of IoT and digital twins having increasing computing power, emulation, and real-world response have taken more and more of a center stage as you start looking at how IoT devices have become increasingly sophisticated, and you get more and more processing power at a smaller scale. And you just have to look at the evolution of things like the M1 chip in Apple, what they've gotten down to in a laptop with the system on a chip concept, and what that potentially means for IoT devices and their ability to process things and the emulation of digital twins. As a result, we like to argue that IoT devices and digital twins are assuming an identity in their emulation of a system that must be managed like traditional user identities and leveraging the principles of what we call zero trust architecture. IoT and digital twin identities also stand to benefit from things known as selective disclosure and zero knowledge proofs, which are the heart of decentralized identity or self-sovereign identity to protect patient privacy and security as part of digital twins in the healthcare environment. So let's talk for a minute about what identity is and putting in the context of zero trust architecture. It's the information on an entity that is used by computer systems or in a digital environment to represent an external client. And that client may be a person, a system or service or device. And I think a little of what we're suggesting here is that the device may in fact be the same thing as a person, or the person is represented entirely by the device, the digital twin, and the important ramifications of both technical and compliance needs to consider there. So from a zero trust standpoint, client identity could be the user account or any associated attributes assigned by the enterprise, to that account, or the artifacts to authenticate automated tasks, such as what you get in a digital twin in its representation. So self-sovereign identity starts with the notion that we are all makers of our own identity, online and off. It is built around principles of human rights and the UN Sustainable Development Goals. Because they don't rely on a centralized authority for identity, self-sovereign identity systems are what we call decentralized, which mirrors the way that identity works in real life. If you think about the concept of a decentralized identity in the physical world, you can present one driver's license for authority to be able to operate a motor vehicle. Maybe you've got some other identity you present as part of logging onto a game and existing in a virtual world. There's another identity you present for access to a facility or participating in a group. Each of those are aspects of your identity that you're controlling. Whereas nowadays in the digital environment, it gets much more challenging to differentiate between those and not have all of those elements out of your control through centralized identity means that are growing in popularity. So self-sovereign identity systems use blockchain as part of those decentralized identifiers, which are a standard created by the World Wide Web Consortium, so that they can be looked up without using a centralized directory, a centralized authority. They also manage the presentation of something else we call verifiable credentials in the W3C to exchange those decentralized identifier information. So what does that have to do with digital twins and IoT? And Nelson, I believe I turned it over to you for a little bit of the commentary.
No, excellent. Great intro, of course. And definitely the whole topic of self-sovereign identity is a large topic in the industry, especially as it pertains to things like your own personal identity from a healthcare perspective, healthcare identifiers, and so on. It also is a big portion of what you talk about or hear about in the Web3 space. So this idea of retaining or bringing back your ownership of your identity, as opposed to freely giving it up to anybody and everybody or other organizations, large organizations, shall we say, that concept is actually getting a lot of interest and traction. And so the theory here is that I can take those self-sovereign identity concepts and apply those to IoT. And so we're going to talk a little bit about that, that concept, of course, and how that can be. So just a couple of other background bits and pieces of information here. One of the things that's important to understand when it comes to self-sovereign identity and the roles that are associated with it is really this notion of what's referred to as the trust triangle. And so you can look at it as three main parties, three main roles. And so, for example, you'll have an issuer, and that issuer is the issuer of some sort of identity or credential. And so typically when it comes to people, this is things like government agencies, these are banks, these are some sort of trusted role that you can essentially trust to make sure that the identity information that they're providing is accurate and is not really trying to represent somebody that is not how they're being represented appropriately. So, so there is that idea of an issuer. Now, of course, when it comes to IoT, you can actually include the manufacturer into this particular picture. So in this particular case, the manufacturer might be the issuer of some set of credentials, some form of an identity that's associated with the IoT device that they've been creating. And we'll talk about that here in a little bit more in the next few slides. Now, the second role that you often run into is this idea of an owner or a holder. So as an issuer, I can issue credentials, and then that is going to be held by another party. Now, in the case of personal identity, that's going to be us, right? We're going to get credentials issued to us by a bank, by an employer, by a government agency, some trusted authority, and then I'm going to hold that in a form of a wallet, as an example. So again, you may have a situation here where I could have identity from an IoT perspective being held, and it could be held by that device, or it could be held by something that represents that device. Then you have verifiers, and verifiers are organizations, people, some other element that's looking to verify either credentials or claims about a particular set of credentials and also the identity itself. So the verifier may operate or interact with these other parties in the trust triangle to try and achieve the validation verification that the who you say you are is actually who you actually are. And again, that's going to be done through a number of different mechanisms that we'll talk about. But these are typically the roles when it comes to self-sovereign identity and what they refer to as a trust triangle. And as we've gone through, when it comes to IoT, each of the parties that are involved in the IoT process can actually be mapped back to each one of these roles. Now, Jim did mention that there's this element of verifiable credentials. And credentials themselves are quite complicated. There's many different forms. When you look at credentials, people have passports, they have driver's licenses. There's many different ways in which credentials can be represented. And to exchange all those credentials across the globe to all the parties that are interested, that can, of course, be challenging because everybody's dealing with different formats and different structures, and there's different data elements on these credentials and so on. So there is this idea of a more standardized form of a credential called a verifiable credential, or a VC, where there is this attempt to define a credential in a standard way to make it easier to exchange. And so that's what you see here. There's an aspect of the credential that is the sort of the metadata that's associated with it. You have different claims or attributes that are associated with that credential. And then you may have one or more proofs that are also associated with that credential. But think of this as a standardized, almost like a standardized data format that can be used across the trust triangle as a way to streamline the exchange of information. Now, there's some other things, other elements here that are also associated with self-sovereign identity, and these also have a mapping to things like IoT. So for example, you have this idea of a wallet. A wallet is typically it's a digital wallet, and it's a place that's going to hold things like keys. It's going to hold different credentials that have been issued by the issuer. It's a place to actually manage and be your primary integration point to other parts of the identity triangle. So this could be held on a mobile device, or conversely, you could actually have a wallet on an IoT device. Right, so think of it, the IoT device as having a embedded form of a wallet, and that is going to be used to facilitate the exchange of credentials and identity information. Decentralized identifiers, think of these as unique identifiers. It's almost a key and a key value pair. So it's going to identify a certain subject. And as Jim mentioned, that can be a person, but it can also be an organization, a thing, some abstract entity, whatever it is that you're trying to represent. You're going to associate a decentralized identity with that. And these are also decoupled from underlying technology. So you'll see that a lot of these concepts don't really depend on the actual implementation. They're abstracted out so that they're easily transportable and easily adaptable to different implementations. You're going to have DID documents, which is where, again, you're putting all the information around your identity and the claims and the attributes and information about the public keys and all this sort of data that's associated with the identity. So think of it as the value in the key value pair. And then you have other things like DID-COM, which is almost like a protocol that allows for more peer-to-peer or more point-to-point based identity exchanges. That can be using any sort of mechanism. And then you have DID methods, which again are abstraction layers. So if I want to get information from an underlying registry, I'm going to do so through a DID method so that as a consumer, I don't care about the underlying implementation. So there's a number of other things that are related, but these are some of the key elements that's important to understand when it comes to self-sovereign identity and the applicability of those concepts to IoT and digital twins.
And if I could mention real quick,
Absolutely.
Nelson, that all of these standards you talked about and excellent summary overall are foundational to things like the new EU EI-2 digital identity and digital wallet standards, the Pan-Canadian Trust Framework. So everything Nelson went over and that we've discussed so far are standards that are being incorporated into digital identity systems and trust frameworks in a number of countries right now, and will build upon, I think, for what Nelson and I have discussed in IoT. Thank you.
Okay, perfect. Yep, no, it makes a good point as well. And you can layer these things together so that you can start to combine and get a visual in terms of how these technologies are related and how the different players in the trust triangle use these technologies to work with one another. And I'm not going to walk through all these things. A couple points here are important to make. One is that the verifiable data registry, that can actually be implemented in a variety of different form factors. So Jim mentioned blockchain. That is one of the areas that is typically used as the example of a decentralized implementation of a registry that underpins self-sovereign identity concepts. But because of the DID methods and the abstraction layers that are defined and so on, it doesn't necessarily have to be. And in fact, there are other techniques out there that eliminate the idea of a verifiable data registry and actually move to more of a concept that's based around things like key event logs and more peer-to-peer or direct DID-COM related interactions. So you will see that as well. And this diagram has it on here where you can have actually holders directly exchanging credentials with other holders without going through any intermediary or any other data registry. So just be aware that some of these other patterns are also available for organizations to investigate. Now, when it comes to IoT, there, of course, are a number of challenges when it relates to identity and IoT. You have challenges in terms of managing what are typically used today, things like certificates. So how do I deploy those to IoT devices? How do I maintain them? How do I upgrade them? That's going to be one of the challenges that you see today with IoT and identity. The metadata that's associated with these devices also tends to be scattered. So there's no one view and no one verifiable view of the metadata that defines that IoT device. It's in different systems, it's out of date, it hasn't been updated, it's out of sync, you don't have the complete history, the background. It can be challenging to find out all the information about every single device that you have since it was deployed. And then you also have situations where to verify a device identity is dependent on a third party. So now you introduce an additional element of trust. Now you have to trust the third party and the information that they're providing to you. And it's also another attack vector. So now you have a situation where if that third party is a centralized third party and owns that information, you've now introduced another attack vector into the equation where some malicious actor can go and attack that third party and either get control of the information or denial of service attacks or whatever it happens to be, which can definitely influence and affect the way that you're using identity along with your IoT devices. These are the three that I typically run into. And Jim, I don't know if you want to elaborate and add some other elements here from your background, but just wanted to bring these three up as well for this session.
Absolutely, great summary. And as we talked a bit before, Nelson, about zero trust architecture, I think you've hit upon some of just the ideas that many people are familiar with the importance of IoT devices or SCADA control and control networks. Certainly within power plants and manufacturing, as any one of those IoT devices has more and more computing power resident with it. If you think about it, that's an attack vector, and being able to use that one compromised IoT devices to attack other aspects of the network becomes a challenge. So that ability to do individual authentication and apply zero trust principles between those devices becomes, I think, more and more critical for the reasons you've laid out here.
Okay. Yeah, no, that makes sense. I mean, especially as devices become more autonomous and they start to exchange transactions and operations or functions between one another, and even get into things like micropayments, making sure that these devices know who each other are is going to be tremendously important in such a world. So just kind of the last slide here before we get into some of the conversation, discussion, the questions and whatnot, and just to kind of give some ideas, thoughts around how self-sovereign identity concepts can be applied to device identity and subsequently to support digital twins. You can see, first of all, you've got this idea of being able to create a unique fingerprint for a device. And there's work now being done to look at different techniques, such as things like cryptographic anchors. So that can be something that's really almost embedded as part of a device so that it can't be removed or changed. So it is typically done during the manufacturing process. And actually that anchor can be also written to a blockchain so that you have a record of that, again, unchangeable or very challenging to change fingerprint. You have a record of that in some form of a tamper-resistant data structure that can be shared across multiple parties. So that's one thing that, of course, can be applied here. Tamper-proof packaging. You can do things like hyperspectral imaging, which is starting to try and again create a unique fingerprint for a device or some other piece of equipment or whatever it might be. You then can also apply things like the wallet concept that I talked about previously. You can then bake that into the manufacturing process, bake that into the device itself, or for the devices that have the capacity to support such a thing. You can do things like use trusted platform modules, which are more specialized processors designed to perform cryptographic operations. And again, they tend to have certain capabilities baked into them to prevent tampering. So that can be an element that's baked into the device and then also recorded against a verifiable data registry. Devices could use peer DIDs or DID-COM to communicate with one another. So that can be done through, again, using keys and verifiable credentials to kind of exchange information. So that could be one way to do it. You could use some of these key event logs and these other concepts, again, to facilitate that direct exchange of credentials and information. And they could also then use this mechanism to verify the manufacturer. So you want to make sure that whoever created that device is who you think it is, and that the manufacturer themselves can be trusted, because there's an element of that that's associated with this as well. So those are, again, a few items that we had come up with. And Jim, I'll call upon you again to add some additional color if you wish. But again, there's not a full implementation in the market around using self-sovereign identity techniques for the purposes of IoT and identity. But these are some of the parallels that we're starting to see in some of the conversations that we're having.
No, I agree. And I love the fact that you highlighted TPM. I'm sure there's many of the audience that heard about TPM when they tried to upgrade to Windows 11, or else couldn't upgrade to Windows 11 because of what the TPM functions were. But when you think about IoT and the relationship between the application layer and the firmware layer, TPM is critical as part of that. And love to see that you've included it here too.
Yeah, appreciate it. All right. And with that, Jesus, I think it's going to be back to you to coordinate whatever random questions that come in. I know from the session that we did this morning, we can expect a whole wide variety of questions. So looking forward to this session here as well, and see what questions you've got.
Excellent, excellent. Yes, and while people still submit their questions, I do have one question, and let me start with you, Jim. Interested to get your point of view from I guess public healthcare point of view, right? So what are some of the most innovative examples that you've seen, or use cases that are being addressed by digital twins in healthcare today?
A great question. And, digital twins in healthcare are still evolving. I think what you see in the market that's particularly interesting in healthcare is the relationship between wearables, your Apple Watch, other devices, and IoT. And I think a continuous blurring of the lines between something we might just as consumers call wearables and something you might consider IoTs as part of a network, and especially how those devices collect data and potentially make that data available in things like your Apple Health Kit, or maybe even back to your electronic health record. And more or less, I guess, backing our way into a personal network of IoT devices and something of a digital twin that comes along. As more and more commercially available therapeutic products or consumer wellness devices come along that are leveraging AI and ML as part of that are collecting information from your wearables, oops, you wake up one morning, you've created a digital twin of yourself. And thinking through some of, both the architecture implications of that, the policy implications of that, the ethical implications of that, I think now is a great time to be talking about this and coming up with ideas to address that, to protect the user and the consumer and reduce liability for the organization that's implementing them.
Yeah, great points, great point. What about other industries, Nelson? What are you seeing out there?
Yeah, I mean, definitely, you can pretty much go across almost any industry and now start to see examples of where, even if it's not a full digital twin, whatever that definition might be to that organization, but different elements of digital twin capabilities are being introduced again across any vertical. Manufacturing is probably one of the ones that you see a lot of, where people are creating digital twins that represent a manufacturing process. And I always say there's two types of digital twins. So yes, you can use it to represent people as well as, of course, devices, processes, and so on. But there's digital twins that are built for the purposes of simulation. So again, if I'm going back to manufacturing and if I want to tweak some parameter on my manufacturing line and see what the effect might be, it's going to be much cheaper to do that against my digital twin and simulate a bunch of different use cases and whatnot through that digital twin than it is for me to go to the actual factory floor and make those changes. So there's that simulation side, but there's also the real-time element of a digital twin. And I call these parallel digital twins. They're parallel to the entity that they represent. And so this would be if I go back to manufacturing, if I'm tracking a product, let's say, right from when the raw materials arrive to the entire process across the manufacturing floor to whenever the final good is actually created, and even after it gets delivered and used in something else, that I can have a real digital twin that's tracking and receiving from IoT as an example. And hopefully those are IoT devices that you know the identity of. But I can go ahead and see at any particular stage in that process how that digital twin is performing. So then I can start to do things like predict how the manufacturing process is going to perform based on the attributes that I've collected at that point in time and based on analytical models, again, based on historical information and so on. So, a manufacturing process is a great example of digital twin, but I can apply it to transportation and logistics. I can apply it to a customer in a retail context. Jim's already done a fantastic job of describing how it applies to healthcare. I can apply it in gaming. There's a number of areas where the notion of either a simulation-oriented or historical digital twin can be applied, as well as a real-time or parallel digital twin.
Yeah, no, for sure. And in many ways, we're just getting started, right? With in many industries, right? Like with exploring how digital twins can be leveraged for a wide range of use cases. But and I know this is hard to predict, right, in terms of where this concept will go or how much it will evolve in the next several months. But from your side of the world, I mean, what are sort of like your predictions, right, in terms of, there's, for example, right now, the connection that we're talking about, digital twins and IoT, what are some of the other areas where this concept will continue to expand or evolve?
I'm sorry,
Jim.
go ahead, Nelson.
Yeah, no, I was going to add one, and I was going to turn it over to you. So
sounds good, buddy.
Yeah, it's all good. I think IoT is really the first most natural fit for a digital twin. That's the way that I'll start that off. And because being able to create a digital twin that represents a physical device and how that device is going to operate or perform either independently or collectively to represent something, I think is the most natural first element and first fit. I think you're going to see then the incorporation of that device information and those device digital twins be aggregated to form some form of a digital twin of a process. So try and derive how you might, again, interact across a manufacturing floor. That's going to be a whole series of what might have been smaller, kind of more discrete digital twins. They'll start to layer and kind of build upon one another. So now you can get the digital twin of a process. Who knows, maybe somebody takes it to go so far and build a digital twin of an organization. So I can run simulations now. If I tweak this part of my organization, what impact will that have? That's probably a little forward out there, but with all the talk of the metaverse these days in the industry, maybe it's closer than what we think. But I think you'll see this progression, these layers. Yeah. So Jim, I'll turn it over to you.
Oh, sure. I would just add a quick comment, especially with regards to digital twins and organizations. What you're starting to see in healthcare, especially as there's more AI and ML involved in data science, is much as Nelson was suggesting, the idea of digital twins around some care plans. So as different chronic conditions and chronic care management become more and more prevalent as a cost of healthcare, as a function of healthcare, monitoring those chronic conditions in ways and collecting data that you can do digital twins to understand, how can I emulate what a particular oncology patient has to do and the response to chemotherapy. Are there ways to be able to model that patient flow around when they get treated and how they get treated that ties back to their specific conditions and prevalence of cancer? All of that can become digital twins where, of course, you want to obtain that information and obtain it from patient-driven outcomes, but you don't want to just experiment on an individual and trying to gather that information. So that's ways that digital twins can probably contribute to improving and optimizing how care is delivered. Yeah,
no, for sure. Yeah, simulation.0, right? Yes.
Metaverse, just like Nelson said.
another conversation, another session.
That's right.
Well, we're getting here to the bottom of the hour, but let me address one question that came up here from the audience, and I guess this is for you, Nelson. Question from Christopher: does TIBCO have a reference solution or example with the digital twin and self-identity implemented?
So digital twin, absolutely. So we have a number of examples where we've built digital twins and have incorporated IoT into that digital twin, both actually in a historical or simulation context, as well as in a live or real-time parallel context. The application of self-sovereign identity concepts to that is where it gets new. So I would say that a lot of work that we have done in terms of joining those two concepts together is more, I'm going to call it research oriented. I won't be able to point to 100 different customers that are doing all of the self-sovereign identity things and have applied that to digital twins and IoT, because I don't think that fully is even in the industry fully baked yet. But definitely it's conversations that we're having. People are obviously very interested in it because, as I mentioned earlier, as devices become more embedded in what we do, and in terms of being able to act as a data source for these digital twins, making sure that we're collecting information from verifiable, properly identified devices is going to become more and more important. The last thing we want to do is have a rogue device get introduced into the system. Who knows what impact that is going to have on the decisions that a digital twin is potentially driving. So definitely on the digital twin side, IoT side, those kinds of things, absolutely. Incorporation of self-sovereign identity concepts, more research oriented in nature and investigative in terms of where and how that best fits.
Yeah, and if you want to get more information on some of these examples, feel free to send us an email at tibcolabs@tibco.com, and we can get you that information. So with that, let me thank both of you, Nelson, Jim. Thank you for this very interesting conversation, and looking forward to part 2 of this.
Thank you very much.
That's good.
Thank you, Nelson.
Thanks all. Talk to you later.